Hello, I'm Dr. Derek Keats, a former professor of biology, and I'm going to introduce you to the human endocrine system. We will cover the basics of the endocrine system, where the components of it are located in the body, and we'll introduce the concept of hormones. The human body. We all have one, even me, for the time being anyway. But how well do we know our bodies and how they work? Perhaps not as well as we might, huh? The human endocrine system is an exciting part of the life sciences curriculum because it's all about us, our bodies, and how they work. I don't know about you, but I like knowing my body and how it functions, at least a little bit anyway. You remember when we had the 2010 World Cup soccer here in South Africa? Imagine a soccer team. When it's playing the game, it pretty much knows what to do, and it follows a set of rules and strategies. But there's not just the players in the team, are there? There's also a coach. And there are times when the coach needs to send a message to the team in order to change strategy or to do something differently during the game. There are signals that the team have agreed to for doing this. We can think of our body as a team. Mostly it knows what to do, but sometimes the endocrine system coach needs to get a signal out there to change something. So the endocrine system is like a coach signaling the players within our body to change something. Only there's not just one coach, there's several, and they're not all in the same place. So let us start with the location of the components of the endocrine system in the body. There are components located in and around the central nervous system, components located within the alimentary system, and components located within our reproductive system. The central nervous system components of the endocrine system consist of the hypothalamus, a portion of the brain that links the nervous system to the endocrine system via the pituitary gland, the pituitary gland itself, which is a small pea-sized protrusion off the bottom of the hypothalamus at the base of the brain, the pineal gland, which is a small body about the size of a grain of rice, and the thyroid, a large gland found in the neck below the thyroid cartilage, or the Adam's apple as we refer to it. The alimentary system components consist of a number of well-known organs and glands. It includes the liver, whose function includes detoxification, protein synthesis, and production of some of the chemicals necessary for digestion. The stomach also plays a role in the endocrine function. After the stomach, there's a small curved region that is actually the first section of the small intestine, and it's called the duodenum, which, not surprisingly, plays a role in the secretion of hormones involved in digestion. The pancreas is involved in regulating metabolism, and aside from its endocrine function, it's also a digestive organ, secreting pancreatic juice containing digestive enzymes that assist the absorption of nutrients and digestion within the small intestine. The kidneys are organs, substantial organs, and they serve several vitally important regulatory roles. They're perhaps best known for their role in the urinary system, as well as for the homeostatic functions such as regulation of electrolytes, maintenance of acid-base balance, and regulation of blood pressure via maintaining the salt and water balance correctly. They serve the body as a natural filter for the blood and remove wastes which are diverted into the urinary bladder. Some of their role, though, is endocrine in nature. The adrenal glands are well known for producing adrenaline, which controls our fight or flight response, but they also have a variety of other endocrine regulatory functions as well. The reproductive system components are also important within the endocrine system. You may recall that gonads are the organs that make gametes. In males, they are the testes, and in females, they are the ovaries. The ovaries play a prominent role in the endocrine system, as do the uterus during pregnancy, as well as the placenta, also when the woman is pregnant. In males, the testes also serve an endocrine function. Now let's go back to our soccer team. The players, our body, the endocrine system coach communicates with the body, making use of chemical substances called hormones. The endocrine system is thus the system of glands, each of which secretes a type of hormone directly into the bloodstream to regulate the body. A hormone, then, is a chemical released by a cell or a gland in one part of the body that sends out messages that affect cells in other parts of the body. We can think of a hormone as a chemical messenger that transports a message or signal that has a purpose from one cell in the body to another. And that's the basis of the endocrine system. We have introduced the human endocrine system. We've explored the location of the components of the endocrine system within the body, and we've introduced the concept of hormones. In the next section, we will look in more detail at hormones and some examples of how the endocrine system functions. I'm Derek Keats, and this resource is licensed under a Creative Commons Attribution License.
Jesus was a human, fathered by a God and born to a virgin. He was dead for 3 days and resurrected. His death was a sacrifice, an offering or propitiation. It brings favor to humans. He lives now in a realm where other supernatural beings interact with each other and sometimes intervene in human affairs. Gradually, the mainstream of the American public is becoming aware that none of these elements is unique to Christianity. Symbologists or scholars who specialize in understanding ancient symbols tell us that the Orthodox Jesus story, as it appears in our Gospels, follows a specific sacred or mythic template that existed in the ancient Near East long before Christianity or even Judaism. In part, this is due to the flow of history. Religions emerge out of ancestor religions. Though the characters and details merge and morph, elements get carried through that allow us to track the lineage. The Gilgamesh and Noah flood hero stories are similar because the Hebrew story descended from the Sumerian story. The same can be said of the Sumerian descent of Inanna and the Christian resurrection story. Even religions that exist side by side borrow elements from each other, a process scholars call syncretism. But another reason for similarities among religious stories is that all of them are carried by human minds. To quote cognitive scientist Pascal Boyer, "Evolution by natural selection gave us a particular kind of mind, so that only particular kinds of religious notions can be acquired. All human beings can easily acquire a certain range of religious notions and communicate them to others. Our supernatural notions are shaped by the built-in structures that let us acquire, sort, and access information efficiently, especially information about other people." You may have heard the old adage, "If dogs had a god, God would be a dog. If horses had a god, God would be a horse." Humans are more inventive than dogs and horses, and not all human gods or magical beings have human bodies. They do, however, have human psyches, minds with quirks and limitations that are peculiar to our species. Philosopher John Locke believed that the human mind was a tabula rasa, a blank slate. We now know this not to be the case. Because we humans need to learn so much, so fast, certain assumptions are actually built in. This allows us to generalize from a few bits of data to a big fund of knowledge, it lets us know more than we have actually experienced or been told. Let me illustrate. If I tell you that my guarg, Annie, just made a baby by laying an egg and sitting on it, your brain says, guargs, not just Valerie's guarg, are non-human animals that reproduce by laying eggs. You have different categories in your brain for animal reproductive systems, and putting one guarg in the egg-laying category puts them all there. To oversimplify, we have a built-in filing system. Most of the labels actually start out blank, but some of them don't. The pre-printed labels appear to include human, non-human animal, plant, man-made object, and natural object. A large percentage of our mental architecture is specialized, quote, domain-specific structures for processing information about other humans. We Homo sapiens sapiens are social information specialists. That is our unique niche in this world. Our survival and well-being depend mostly on smarts rather than teeth, claws, stealth, or an innate sense of direction. And most of the information we need comes from other humans. Our greatest threats also come from our own species, people who seek to outcompete, exploit, or kill us. For this reason, our brains are optimized to process information from and about other humans. So how does all of this affect religion? Here is a concrete example. Our brains have a specialized facial recognition module. Much of what is known about the inborn structures of our minds comes from the study of infants and brain injuries, and we know about the facial recognition module from both. Shortly after birth, babies are uniquely attracted to two round circles with a slash beneath them. Later on, brain injury or developmental anomalies can produce a disorder in which people cannot recognize faces, including their own, even though other kinds of visual processing are perfectly intact. This is called prosopagnosia. Most of the time, though, our facial recognition module overfunctions rather than underfunctions. In ambiguous situations, looking at clouds, rocks, lumps of clay, or ink blots, we have a tendency to see faces. Our brains automatically activate the facial recognition machinery even though it doesn't really apply. Through history, people have seen gods, demons, ghosts, or the man in the moon looking at them. Christians, whose interpretation of hazy shapes is further shaped by belief in specific supernatural persons, see Jesus, the Virgin Mary, an angel, a demon, or even Satan. This illustrates a broader point that cannot be overemphasized in understanding the psychology of religion. When faced with unknowns and ambiguities, our brains activate inborn information modules even when they don't really apply. We take unfamiliar situations and even random data and perceive simulacra, meaning patterns that are inherent not in the external world, but in our own minds. Furthermore, our pattern recognition systems err on the side of being overactive rather than underactive. This is called apophenia.